Hey everyone, welcome to the channel. My name's Nader. In this video, we're going to go over exception handling, specifically the throw keyword in JavaScript, as well as try and catch blocks and how they kind of relate to error handling in JavaScript. This is going to be an important topic going forward, pretty much for everything, because errors are going to pop up all over our code as we build different types of applications. But it's going to be especially useful when we look at async await next, which is a newer syntax on top of promises, which you just looked at earlier. Because that syntax specifically doesn't actually have a way to handle errors beyond the try catch block that we're going to learn here in this video. So not only is this useful for that, but it's going to be kind of coming up all over the place as we look at JavaScript together. So let's kind of get a handle on it and see how it works together. Let's take a look. Okay, so let's just start with kind of the concepts and rationale behind what exception handling even is and what these fancy words are and kind of what happens with errors in our code in general. So this concept of exception handling, the word exception kind of, you can replace it maybe with like error handling, right? So an exception is basically an error, something that is exceptional that happens in our program that we don't really expect. Okay, and it might seem like it might not happen because coding so far, as we've seen, seems pretty kind of deterministic. However, as we'll see, there's going to be many times where we're actually not going to be sure what might happen in our program, and we need to be able to kind of figure out what to do in those cases so that our program doesn't basically crash. Okay, and handling kind of is that word, which is like, how do we handle these cases? Like, what do we tell the computer or JavaScript to do in the cases where we do have these exceptions or do have these errors? Okay. So let's think about it right now. Up until now, what actually happens when there's an error in our code? Well, we've seen it a few times, right? Basically, what happens is our program just crashes, right? Like Node.js kind of crashes. We get this really scary looking message and it kind of says like some kind of error over here, error over there. It sometimes is helpful and gives us like a line number or like a snippet of code where that might actually be happening, kind of like an excerpt of where that's happening in the code. But if you really think about it, that is not really ideal, right? I want to kind of post like a scenario to you, right? Like, let's imagine that you're writing a JavaScript program for like, say, let's say we're going to go to space. Okay. And your JavaScript program is meant to keep like, let's say the life support system for the spacecraft functioning. Okay. So imagine that pretty much 99.9% of the time, maybe everything is running smoothly. Okay, and their code kind of works as expected. But there's like a 0.1% chance or even lower chance that there might be something funky happening, right? Maybe the math works out in a certain weird way, or maybe something might be missing, or maybe some of the values aren't really what we expected. And then that might cause a problem in our program. Like maybe we miscalculate something, or we end up with undefined for something. And then if we try to do some calculations with that or try to do some code using it, there's a chance that it'll actually crash our program, right? Or maybe it'll just propagate that error further into our program and it will cause kind of bugs and issues to happen further on. So that would be very bad, right? In the case of, say, a life support system, if our program just crashed as a result of kind of these errors, that would be terrible, right? Because then how do you restart it? How do you be sure that in the future when that bug happens again, that it won't just crash again right after you restart it up again, right? Like that, those are all very, very scary scenarios, and we really wouldn't want those to happen, right? So this kind of example might seem kind of like intense, right? But there have been many disasters that have happened as a result of small programming mistakes. There was in fact a spacecraft that kind of had some programming mistakes in it, as well as some engineering mistakes as well. And kind of a combination of all these things caused it to actually unfortunately explode after it was launched, okay? So these are things that happen in real life, and we need to figure out how to actually deal with errors in our code a bit more gracefully. So when you think of errors in the context of like, maybe we try to do something with something that's undefined, right? If we take undefined and we try to like say the uppercase it, or we try to do some math with it or something, we might end up with an error, right? Our program might crash. If we try to say open a file that might already be in use, right? We haven't seen this yet, but that might also cause some kind of error message. Okay, maybe we try to talk to a database. We haven't seen databases yet, but imagine that we need to talk to some computer somewhere on the internet, and maybe it crashed, maybe it's down, or maybe it's not connected to the internet for some reason. Maybe the internet just went down, right? There's all these different things that are going to start happening. And it's as we start working on more complicated apps that start doing these things like talking to other computers, and we kind of increase the surface area of errors that can happen in our program, this topic becomes incredibly crucial so that our programs don't just collapse and crash every time some small error happens. So the kind of key point here is our program can crash if we don't have error handling, or we can try to figure out kind of what to do with the error if we can actually account for it, and maybe we can recover gracefully, right? Maybe we can kind of error correct and do something in the case of the error when we know what it is, and then just kind of keep going with our program instead of just crashing blindly and having the rest of the code just no longer execute anymore as a result, okay? We also want a way to kind of monitor and maybe log these errors in our program as well in the future. This is a huge topic, and it'll come up as we start building things like servers and databases and things like that together. Okay, so hopefully that helps a little bit with the concepts as to why we need exception handling. So that said, I just want to show you a couple more drawings as like kind of the concepts of an error and how we're going to start introducing them together in this video. So the first one I have is this one right here. So I want to imagine you're this person, okay? You're this person right here. And what you're going to do is, if there's some kind of error that's happening or something that angers you or irritates you or frustrates you, you're going to basically throw a tantrum, okay? You're going to pick up the nearest object and you're just going to throw it across the room. All right. Now, hopefully you don't actually do that in real life, but let's just say in this fictional scenario, that's what happens, okay? So I want you to picture this concept when I'm talking about throwing something, okay? This is exactly the keyword that's actually used in not only JavaScript, but actually many other languages in order to kind of create an error, okay? And this might sound kind of weird. It's like, why would we want to create an error? Aren't we going to try to kind of stop errors from happening that are somewhere else in our code? Well, we're going to actually see this come up quite a lot. And there's many cases where we actually would want to throw this kind of error. And I'll show you why in this video later and in the exercise videos after this. So just picture this scenario of, you know, something happens that's bad and you kind of have a little tantrum and you're throwing this thing across the room, okay? So there's basically one thing that can happen in this case. Well, there's a few things, but the most important thing that'll probably happen if you're kind of in the room by yourself is it'll probably hit the ground, right? This object will hit the ground and it'll kind of break or collapse if it's something breakable. And in this case, the analogy is that our program is going to crash, right? So this is what our programs are doing right now. We're not really throwing an error ourselves. Some error might have happened in our program before, but if we just kind of ignore it, right? And nobody's there to kind of listen to this error happening or help us out in any way, then it's going to hit the ground and it's just going to crash, right? Our program is just going to stop running, and that's going to cause all the other code that we could have run in our program after that to not have run. Right? So we have no chance of running any more code in our program because the program just basically stops, right? So that is not usually really great, right? Most of the time we don't want this to happen. We want a way to kind of realize that an error happened and then maybe have a chance to actually deal with it. And then we can decide whether the program needs to kind of stop and maybe we need some human intervention or something, or fix some other bugs in our code, or whether we can kind of gracefully recover from this scenario. Okay, so this case is this one right here. So imagine we throw this object across the room, but there's a helpful hand on the other side of the room, and they are able to catch this object for us. Okay, so funnily enough, we're actually going to see this terminology almost exactly pop up just like this as we code in JavaScript together. In this case, we are not going to crash the program. Okay, because we have someone who's helping us out, who's ready to kind of catch that error for us after it's been thrown, so that it doesn't actually just hit the ground and collapse and break and stop our program from running. Okay, so we can set these people up to help us throughout kind of our code, and they can be there to help catch these errors that pop up so that we don't actually hit the ground and break and crash our program. Okay, so that said, let's kind of get into the code and see how this might work with throwing first, and then we'll look at this kind of catch concept right after. So I'm going to pull up Visual Studio Code. I'm just going to create a new file. I'll call this throw.js. Now in here, maybe I'll just zoom in a tiny bit more since I don't need too much space. In here, I'm just going to simply write throw, and I'm going to kind of just give it a message here. Like, for example, there was a bad thing that happened. Okay. And that's kind of my little error message. Okay. So notice that this new keyword, right? That's the one that I mentioned kind of in that analogy. This is an actual keyword in JavaScript as well as many other languages. All right. So I'm just going to pull up my terminal here. I'm going to make sure I'm in the correct folder, and I'm going to run node and then throw.js. And what you'll see is kind of something that we've kind of seen before, which is like the file that something bad is happening in. The message is not as crazy as some of the other messages that we've seen with Node, that we've run things where we have like a syntax error or a type error or something like that. But we can kind of see that, okay, there's an error right here where this is where kind of it's happening in our code, and this is the error that happened. Okay, so I'll just show you something. If I have a console.log after this, and I say like hello, right, and I rerun this code, we are not going to see hello printed out. Okay, because as soon as this error happens, there was kind of no one to help us catch this error, and this hello never gets a chance to run because our program just shuts down and crashes. Okay, so any code that we had down here after this error is basically unreachable code. It would never run because this error is going to prevent us from reaching that code down there. Okay, so how can we kind of get around this, right? So that was kind of this idea. How can we kind of make this happen, right? Where we're throwing something, but then we have someone set up to catch it. So that's where we kind of get into this concept. That's where the exception handling, a kind of control flow comes in. We can use these keywords right here. I'm going to ignore this finally keyword for now. I just want to kind of keep it in here for the sake of completion, very similar to the promises video, but we'll get to that kind of in future videos as we actually need it, just so we don't get confused. So to start, these are the two that we really need to know: try and catch. Okay, so if we have a try and catch, then we have a chance to kind of do this, which is catch something that is thrown. Okay, so the way that this works in JavaScript and in many languages is we kind of have to tell JavaScript the code that is kind of risky, right? The code that we think might throw an error so that JavaScript can be ready to catch it from that specific section in the code. Okay, so what does this look like? It looks kind of like this. Okay, so right now we kind of have something like this in our code, right? We have throw and then a message, right? So if we surround that with this new syntax, a try block, right? So try and then curly brackets, and then the code that we think is error prone, for example, or might have an error or has a potential for an error. And then we follow that up with a catch block, which is the catch keyword with the curly brackets as well. Then we have a chance to catch any code or any error, that gets thrown by the code inside of this try block. So let's take a look. So if I come back here and I create a new file, I'll call this try catch.js. I'll just zoom out a little bit just so I have a bit more space. And I'll do try here. And I'll say throw boom, just like that. And I'll say catch. And I'll say console.log caught, right? Just like that. Now down here, I want to just see if I can do a console log. Okay, so previously we saw that over here, right, if we just throw the error message, which is a string in this case, and we'll see how we can throw other types of objects later. But if we throw this error right now and we try to console log, we saw that we never get down here. We never get to any of this code after the throw, right? So let's see what happens here, right? So we're telling JavaScript to try this code, right? And in the event that something bad happens, in this case, an error gets thrown, then kind of catch it, right? Set someone up to catch it and then do this code over here. So let's see what happens. So I'm going to run node. I'm going to do try catch.js, and look at that. right? We get our catch message, which is caught right here, printed out. But then we also get a chance to come here down to kind of line 7 in my case and actually print out the hi message. Okay, so this is fundamentally different from over here because we never got a chance to come down here. Okay, cool. So what I want to show you next is kind of an extension of this idea. How do we actually get access to that error message, right? So like, let's say that we throw that error message, but then in the catch, we want to be able to kind of know what went wrong with that error message. So we kind of need access to stuff up in the try block so that we can kind of get it passed to us so that we can actually use it. That's what I'm trying to illustrate right here. The catch block actually kind of works almost like a function. You can think of it like a function, right? If we provide it with these brackets right after the catch, and we give it a name for that parameter, and we can name this whatever we want, right? Some people use just E, some people use ERR. I'm just going to spell out the whole error just so it's super clear, right? But we actually get that message that is thrown, or the error that happens inside of that variable as an argument if there is an error in the try block. Okay, I actually forgot to mention that I'm actually switching to console error here instead of console log. And that's because generally speaking, if you have an error message, you kind of want to log it out differently than you would something that's not an error message. We'll see this a lot more when we start working with like web development, for example, but I just want to get in the habit of that if it's an error to kind of show you that that's another function of the console API that we can actually use this error portion to actually log out errors. Okay, this just displays them differently and is treated slightly differently depending on the environment that you're running JavaScript in. Okay, so let's try this out. Let's kind of go back to our code. And let's say I want to kind of get access to this message, which is the error message in this case that's being thrown. All right, what we can do is I can put brackets here after the catch, and I can call this error or error or whatever I want. Right? So this, just like any function, can have any placeholder name. And now I can use that placeholder name down here, and I have access to whatever error ended up being thrown. So now if I rerun this, what you'll see is I actually get access to that boom message, which is what was thrown here in the try block. Okay, awesome. So hope that's clear, and I'll just really emphasize this, that this is just anything that we want, right? So if I name this E, for example, you can see that that works the exact same way. This is just a parameter. All right, cool. And I should probably switch this to console error here and just show you that that works the same way. It's just more semantically correct. I'll leave this one as a console log because technically this is just a regular log, and these are errors because they're happening inside the catch block. Okay, inside the browser, these would appear slightly differently. Okay, cool. Now, next, I want to show you kind of what happens once we start adding more concepts inside of this try block. So over here, I have kind of a demonstration of us actually doing stuff inside of the try block. So that's kind of the purpose of these try blocks. Usually you would not throw an error just for fun inside of there. You'd want to kind of try to actually do something. Okay, so in this case, I'm going to try to create a variable, and I'm going to try to console log out that variable, and then I'm going to throw an error. Okay, so let's come over here, and I'm going to say const message equals hello there, and then I'm going to console.log out my message. And once that's done, I can then throw the error and then catch the error and log out the error itself, as well as my custom message right here. And then at the very end of my program, I can log out hi. I want you to think of what's going to get logged out here before I run this, just to see if you can kind of maybe guess what might actually happen. Okay, so if I try this, you'll see that we get hello there, which is our message, right? Which is coming from these lines right here. Then we throw the error, and then the catch kind of kicks in, right? We catch that error and we store it inside the error variable. We log out error, which is boom. We log out caught, which is right here. And then finally, after this try catch block, we log out the hi. Great. So hopefully that kind of makes sense. We'll see soon in just a couple slides how we can kind of modify this and add some tricks to it and how this might actually be an issue soon. But hopefully that actually makes sense, right? The purpose of the try block is to try running some code that might cause an issue. The purpose of the catch block is to catch the error that might happen as a result of issues happening in the try block. Now, what I want to do is I want to replace this with an actual error that we would want to use kind of in most of our programs. So I just want to kind of bring this up inside of the browser real quick just so we can take a look together. So if you pull up Google, I would like you to look up for error JavaScript. And we want to look at the error object on something like MDN. Okay, so I'm just going to click on this one. And you can see that error objects, if I zoom in a little bit more, are thrown when runtime error occurs. The error object can also be used as a base object for user-defined exceptions. See below for the standard built-in error types. Okay, so it looks like there's all these different kinds of errors. And we can have like eval errors, range errors. As you've seen, we've seen this syntax error before. We've seen a type error before, right? There's been a few of these errors. I'm actually going to scroll down here to the constructor, and I'm going to see that there's this kind of creating a new error object section right here. Okay, so I'm going to click on that, and it's going to take me to this page, and it's saying that we can kind of construct an error object using a new error, and we can give it a message, and we can give it many other different things. Okay, so I would say that let's go ahead and use this for our errors going forward, because this is a common thing that's used in most programs, especially as we start kind of getting into web development. All right, so instead of just throwing a string, which is what we're doing right here, I'm going to throw a new error object, and I'm going to pass it my error message, just like that. Okay, this is actually going to create an object for us, and it's going to give it a message property of boom. So if I rerun this code, now you can see that this kind of works a little bit more as expected with the way that we're using console error. And console error is kind of formatting this in this particular way for us, right? So we can see that right here is actually line 6, which is picking up that error. And we can actually see that this is the name of the error. So this could be a syntax error or a type error. In this case, it's just called error. And here is the error message. Okay, so just to show you kind of how that would work with a type error, for example, if I reran this, because this is another type of error that we can use, you can see that we get a type error here. Okay, we don't have a type error in this case. So I'm just going to stick it with a generic error message. I just wanted to show you that kind of there's different types of errors that can be thrown, and this is kind of how they're generated internally inside the language as well. Okay, so whenever we have code that might have an issue, an error is going to be thrown either by us if we know that there's kind of an issue that happens, and this is a common thing that happens as well, or maybe we just don't realize that an error can happen, and then the code that we're using, if it's someone else's code or even our own code, will have some kind of JavaScript error, and that will be thrown, and we'll need somewhere to catch it, which is what our catch block does. Okay, so just to kind of create another example of this, I'm going to call this try catch custom.js. Oh, sorry, not custom. I meant object.js. I wanted to create a custom code for this. So what we're going to try to do here is work with an object in a way that we might try to work with if we're saying working with a server or a database in the future as we get to those videos, and maybe do something that we think is there but is not really there. Okay, so over here I'm going to create a try catch block just kind of like this, and I'm just going to give this a name of error just because I already know that the code in here might cause an error. So I'm going to say I'm going to create a user object, and this user object is going to have a name of, let's just say Alex, right? And Alex will have an age of, let's just say like 21. Okay. So now let's just say that this is something that came back from some server somewhere. Okay, so maybe we didn't actually create this object. So I'm just simulating that maybe we asked somewhere like Google, or Facebook or something for this object and it gave it back to us. Okay, so let's just say I want to log out something in this object. So let's say I am assuming that inside of a user, I know that there is a profile and that inside of profile that there is a color. Okay, so I want to get to user, to profile, to color. Okay, and if this looks a bit weird for you, you can take a look at the objects video where we kind of go through how this works, where we're accessing different properties off of an object. In this case, we only have name and age for user, but let's assume that we thought that there was a profile and inside a profile there was a color. All right, so I want you to think, is this going to cause an error? Right? So if it does, let's see what happens. So I'm going to do a console.error in here, and I'm going to log out the error that happens. Okay, so I'm going to run node, and I'm going to do try catch object.js. And if you see that, we actually get a type error. Right? So that's what I kind of simulated earlier. So JavaScript, though, is giving us this error now. And the error message is giving us is cannot read property color of undefined. So what it's basically saying is that we're trying to do like a user.undefined.color, which doesn't make sense, right? We can see that user only has name and age, right? So in order for this to work, we would have to have something like profile, then we'd have to have something like color, and then color could be like blue, right? And now if I run this code, what we'll see is that we just get that color printed out, right? But for example, if I try to if I comment out this stuff here, and then we go back to not having that at all, we cannot get something that doesn't exist at all. Okay, if I just tried to get profile, that would be okay because that would just give us undefined. But I'm trying to further split undefined into color property, which doesn't exist. Okay, awesome. I hope that helps a little bit. And the key here is you can see that we're not actually throwing the error ourselves, right? This is a result of JavaScript kind of failing at runtime and then trying to search somewhere, scramble for somewhere to catch that error to figure out what to do going forward. If we didn't have this catch block, our program would totally crash at this point and any code down here would not run. All right. Awesome. So I just want to show one more thing here before we go to scope, which is the last concept I want to cover in this video. Anything that we have after something that causes an error inside of a try block is not going to run if an error is thrown before it. Okay, so in this case, you can see that we have some kind of code here up here that's going to run correctly because this is valid code. I'm just making a message that's pointing to hi, console logging the message. There's nothing that would cause an error here. However, down here, I'm throwing boom, right? Or say throwing a new error with boom, right? What that's going to cause JavaScript to do is jump to the nearest catch block. Okay, it's going to completely ignore any code below this error location. All right, so just to show you that, what I want to do is I want to try to, I want to console log right after here, do I get here, question mark. Okay, so we have our user object. We're trying to grab profile.color, which doesn't exist. This is going to cause an error. Okay, we're not throwing it like in the example I just showed, but JavaScript is going to throw it for us. What that's going to cause JavaScript to do is look for the catch block immediately, very similar to a break statement in loops. We're not ever going to reach any code down here, like lines 10 and 11, inside of this try block. All right, so just to demonstrate that to you, if we look at this, we can see that we just get that error printed out, which is a type error, cannot read property color of undefined. Okay, and if I just do another console let's just say dot error here, and I'll say something bad happened, you can see that this does get run because it's inside the catch block, right? So the stuff inside the catch block will get run unless the stuff in the catch block also has an error. So I don't want to get into kind of error reception here, but we'll just stick with the basic cases for now. All right, so hopefully that makes sense. Now, I want to kind of go into the last topic of this video, which is a bit tricky. When you first use try and catch, and as we start using them with things like async and wait, for example, what's going to kind of become a thorn in our side a lot of the time is going to be an issue with what's called scope. We're going to kind of see a bit more complex examples of scope when we get to topics that are super interesting like closure. However, for now, I just kind of want to give a basic example of how scope works, just so that we have it at the back of our mind, so you can be aware of it when you're using try and catch, just so that you don't run into these issues and can actually resolve them. Okay, so what do I mean by this? So let's take a look at this code right here. Let's say that we have this try catch block. I'm creating a message, hi, logging out the message, and then throwing an error. This is all totally fine so far. We've seen this so far together in this video. That's going to cause this error to be thrown. It's going to look for the catch block, which is right here, which we do have, so our code is not going to crash. And we're going to come down here. We're going to log out the error, which is boom. So that's fantastic. No issues there. But then we're going to try to console error the actual message, right? This message, which is the variable message, is up here in the try block. Okay, so I want to show you what happens. I'm going to go back to VS Code. I'm going to create a new file. I'm going to call it tryscope.js. Okay, I'm going to create a try block. I'm going to simulate that. I'm going to say const message equals hello. Okay, I'm going to console log the message up here. So that's fine, right? No issues there. Then I'm going to throw a new error. I'm going to say, oh no. Okay, I'm going to catch that error. I'll just go a slightly different syntax because you'll see this once in a while as well. Some people just like to call it R because they want to save those keystrokes. And then I'll console.error out the error. And then I'll also console.log out for now the message, just so that we can see the difference. I should probably actually error this just because it's in the catch block, so I'll actually switch that. And I'm going to run this and let's see what happens. So if I run node and I do tryscope.js, let's just kind of go over this, right? Message is here, hello. We're going to see hello. We're going to throw a new error saying oh no is a message. This oh no and the error itself is going to come down here into catch. We're going to console error that error object with the oh no message inside it. That's fine. Then we're going to look for the message variable. Okay, we know because we can see that message exists right here, right? But let's see if this actually works in the context of try catch with JavaScript. So a lot of crazy stuff is happening here. I'm going to try to scroll through because I know my face is in the way as usual. So we see hello to start, right? So that's fine. That's coming from right here. Then we get the error oh no, right? So that's fantastic because that's what we expected. That's coming from line 6 right here. Just scroll down a little bit. Now you don't need to see the rest of this. The important part is right here, right? We're actually getting another error, but this error is causing our program to crash, okay? So just to really emphasize this, I'm going to do a console log down here and I'm going to say program complete. Okay, I'm going to clear this and rerun this one more time. And I know my face is covering this, right? But we see hello and oh no here. We see messages not defined, but just down here, I hope you can see that there's no program complete message. Okay. And I assure you that it's not here, right? There's no program complete message. And that's because this code right here, line 7, it is going to be looking for the message variable and it's not going to find it. And that seems kind of bizarre, right? Because obviously message is right here. So what's going on, right? So really quick, before I go into that, the reason why we never get down here is because we're actually getting an error here. So unless we had another try catch block inside of our catch block, which is what I was talking about earlier with the kind of error reception, this is actually causing our program to crash to catch because we don't have a catch inside of our catch. right? A catch only exists for the try above it. It doesn't actually deal with errors inside of itself. Okay, so that's where we're getting this message, which is a different type of error. It's a reference error, and the reference error is trying to look for a variable called message, which it doesn't exist. So why is this happening, right? This is happening because of something called scope. So a scope is the area in the code where a variable basically exists or is visible. Okay, so if you think of it as two scopes right here, everything in between these curly brackets, in fact, everything in between any set of curly brackets in JavaScript is its own scope. Any variables inside of there can't be accessed outside of it, okay, which we'll see more in future videos as well. But if that's the case, inside of these curly brackets, we have const message, which is going to be hi. We have access to message right here, which is why we can log it out, because we're in the same scope where we declared message, right? We're in this orange scope still for the try block. However, down here, once we get to catch, there's another set of curly brackets. This is a different set of curly brackets, okay? And inside of those curly brackets, we don't have access to the variable that was declared up here in this set of curly brackets, all right? So if we try to access message, it's not defined. It doesn't exist. That would be the same as just trying to log out message as the first line of our code in a program. If you think about it, like for example, if I just got rid of all this code and the first thing I wrote in my program was console log out message, right? If you think about it, this doesn't make any sense, right? Because the question you should ask is, well, where is message? Message doesn't exist, right? And this is exactly what's happening right here on line 7, right? This exact thing. It doesn't see up into this scope. Okay. Now, scoping is a bit complex and there's a lot of things that can go on. So exactly between curly brackets is not always true, but a lot of the times it is true, especially with const and let, and we can take advantage of this, and this is a very useful feature, but just be aware of it specifically in the context of try and catch until we look at it in other contexts later. Okay, so we don't have access to message because it was declared up here. If I created another message here, let's just say const message equals meow, right? And I try to run this code. Let me get rid of this here because message doesn't exist down here. And I try to rerun this. You'll see that I actually do get meow and then program complete, right? Because I am creating message here before it gets printed out inside of this scope right here for the catch. Now, normally you can't create a variable twice with the same name, right? But in a different scope, you can because they don't clash with each other. Now this is ultra confusing, so I'm actually going to get rid of that, and we're going to look into this in more detail later on. I just wanted to show you that kind of for sake of example. All right, so how can we kind of fix this? So that's kind of this last part of the video to wrap this up. Okay, this is probably one of the more important parts, especially as we start looking with promises and async await and many other topics as well that use try catch a lot. We can take advantage of the fact that there's what's called an outer scope or global scope, or even I would probably say outer scope in this case because technically global scope means something slightly different. So if we actually created message outside of this try catch block, right, up here, and then we try to use it inside of try and catch, then it is available to kind of those scopes because it's going to look for a message. And if it doesn't find it in the curly brackets immediately surrounding it, it's going to kind of look up. It's going to like look upwards to see if it can find it. That's kind of the way to think about it. Okay. It's going to look in the scope surrounding it. Okay. So these scopes work from outside in, and inside scope can't access, can access the outer scopes, but out here, we cannot access things inside of these curly brackets. So we'll look into that in more details as we look at topics like closures, but this is an ultra confusing topic. I really understand that it's gonna like probably break your brain a little bit. In fact, I always still mix this up sometimes as I work through the code, but it definitely gets easier as you go through it, and especially as you start to understand concepts like closure. So for now, what we need to know is that here we can have a scope that is available in both the try and the catch blocks. Okay, so let's see how that we can fix our code in this case. If I said const message equals meow up here, for example, and I got rid of message here, and I tried to rerun this code, okay, what we would see is that now it would work. It would not crash, okay? We would see meow being printed out, which is on line 5. We would see, oh no, the error message right here. I think I changed it. I should have probably said hello instead of meow. I got too carried away. But then we see on line 8 and 9, we see our error printed out, and then we see meow printed out. And then finally, our program does complete successfully, right? In fact, now I can even console log in this message right here, and we'll see that we also get that working as well, because this meow is in the same scope as this console log over here, right? It's in the outer scope, or in this case, in the global scope of this code. Okay, so this scoping thing, again, I really appreciate that it's very, very confusing, right? I wouldn't expect you to get this right away. This is just something to keep at the back of your mind as we're going to more kind of topics like async await. As we get to topics like closure, as I've mentioned a couple of times, this will make a lot more sense, and you'll kind of see why this is actually a feature instead of something that's just of an annoyance. So that said, what we're going to do to really get a handle on try, catch, and exception handling and throwing and catching is we're going to go through a bunch of exercises for try catch in JavaScript next. That's going to set us up really nicely to go through async await syntax, which is what I've been kind of anxiously awaiting to get to, which is kind of a modern way to actually work with promises a little bit easier than what we saw in the previous videos. So can't wait to get to those exercises for practice together. I'll see you there.